Question says a small ring of mass 0.2 kgs that makes it 2 Newton weight is threaded on a fixed vertical rod. The end A, okay, if it is fixed, we are not dealing with friction. The end A of the light inextensible string is attached to the ring. The other end C of the string is attached to fixed point of the rod above A. The horizontal force of magnitude 8 newtons is applied to the point B of this string, where AB is 1.5 and BC is 2. The system is in equilibrium, not moving up, not moving down, with this string taut AB at right angles to BC as shown in the diagram. Find the tension in part AB of the string and tension in part BC of the string. So let me call tension in AB as T1 and tension in BC as T2. So before moving forward, we split them up and I'm writing angle alpha and beta. If this is alpha, this is beta, I can split T2 in vertical and horizontal component, and while I'm solving this, I'm considering point B. So when I'm considering point B, we consider forces moving away. So if this is B, forces are moving away, and this is 8, this is T2 and this is T1. To define the directions, this is moving upwards and towards left. So T cos of alpha and this is T sin of alpha, which is opposite to the given angle. Now solving for T1 in the same way, it is moving towards left and downwards. So if this is beta, this is T cos of beta and the opposite one is T sin of beta. Now we have all the split and we can solve around this B point. So upward force equals downward force, that is T cos alpha. This was T1, this was T1, this was T2. T2, T1. So T2 cos of alpha is equal to T1 cos of beta. Now from the same triangle, let me extract that. This is beta, this is alpha, this length 2 is already there, this length 1.5 is already there, and if I apply Pythagoras theorem to find the third length, which is AC, 2 square plus 1.5 squared, square root of answer, that is 2.5. So this third length is 2.5. Now looking at this triangle, I can say cos of alpha is base over hypotenuse, that is 2 by 2.5. On the other side, cos beta base over hypotenuse is 1.5 by 2.5. Now I'm making T2 the subject. So this crosses out, equals T1 into 1.5 by 2, which is 3 by 4 of T1. When we are done with the vertical forces, now we are handling the horizontal ones. So for horizontal, there are 3 forces: component of T2, component of T1 and 8. So towards left hand side is T sin alpha, and this is T2 sin alpha, this is T1 sin beta, and towards right hand side is 8 newtons. Again we use the same triangle. T2 sin alpha is 1.5 by 2.5 plus T1 sin of beta is 2 by 2.5 is equals to 8, and we can replace T2 meanwhile, which is 3 by 4 of T1 into 1.5 by 2.5 plus T1 into 2 by 2.5 is equals to 8. Taking out T1 is common, 3 by 4 into 1.5 by 2.5 plus 2 over 2.5 is equals to 8. Using calculator, 3 by 4 into 1.5 by 2.5 plus 2 by 2.5 is 5 by 4 equals 8. 8 into 4 by 5 is 32 by 5, 6.4. T1 is equals to 6.4 newtons. And T2 is equals to 3 by 4 of T1 which comes out to be 4.8 Newton. First part of the question is done. T1 6.4 and T2 4.8 newtons. Second part says find the coefficient of friction between the ring and the rod. Now we are solving around point A. Now we will not look at force 8, that is on point B. So when we are looking at point A, it says find the coefficient of friction between the ring and the rod. Now when we are considering point A, we will take the direction of tension from A to B away from the point of contact. So let me draw this. This is the ring which weighs, what was the weight? It was 2 newtons. So it weighed 2 newton and direction is now this way, and we split it up. We already know this was 6.4. This is beta. So 6.4 sine of beta and 6.4 cos of beta. Now when we are solving for friction, what do you suggest the direction of friction would be, up or down? What direction would you suggest for friction? The equilibrium is limiting with the ring at the point of sliding up the rod. It is downwards. So if it is at a verge of sliding up, friction would be downwards. And not forgetting R. So left hand side is equal to right hand side 6.4 sine of beta, and we already know what sine beta is using the same triangle, is 2 by 2.5. 6.4 into 2 by 2.5, simplifying it right here, gives me 5.12. So I have R. Now we can write the vertical forces. Clearly we can see 3 of them. One is upwards, which is 6.4 cos of beta, and 2 are downwards, which is 2 newtons, and the friction. So 6.4 cos of beta, again from the same triangle, beta is 1.5 by 2.5. So 1.5 by 2.5 is equals to 2 plus friction is mu R. 6.4 into 1.5 by 2.5 is 3.84. On the other hand, 2 plus mu is unknown, R is 5.12. So 3 minus 2 is 1.84 by 5.12, and we get the value of mu 1.84 by 5.12 is 23 by 64, approximately equal to 0.359.